Hello, ladies and gentlemen. My name is Mr. Tandy. Welcome to Module 3, VLANs, Virtual Local Area Networks, Switching, Routing, and Wireless Essentials. So let's get into this. Let's dive into this wonderful module. So, things we're going to go over in this module. Overview of VLANs. We're going to explain the purpose of VLANs in the switch network. We're going to explain how a switch forwards frames based on the VLAN configuration multi-switch environment. We're going to configure a switch port to be assigned to a VLAN based on requirements. We're going to configure a trunk, and then we're going to configure dynamic trunking protocol. All right, so these are the items that we're going to get into in this video. There's also going to be a demo too in this video, so I'm going to show you a quick little demo on how we're going to do most of this stuff. Okay, so let's get going here. All right, overview of VLANs. Let's take a look at this building right here. Okay, so let's say for a hypothetical situation, you've just been hired. You've just been hired at Marvel Studios. Yes, of course, I'm a big Marvel fan. You just got hired at Marvel Studios, and there are 3 floors. And the boss comes up to you and says, hey, we've got some challenges in this network. We need your help. This is the breakdown. This is the breakdown of everything that's going on here. So you have on the first floor, we have 14 devices, which is the HR department. Second floor, we have marketing department, which has 18 devices. And the third floor, we have 16 devices with a grand total of 48 devices. Okay, so 48 devices. So you understand the breakdown. You understand what's going on. You understand that these are the different devices that are on each of the floors. You understand how they're all separated. Okay, cool. Here goes the next part. The boss says, come on in. I'm going to take you down to the IDF. I'm going to take you down to the networking closet. All right. And he's going to warn you, just be ready because it might be a hot mess. So you go down to the networking closet, and this is what you see. This is what you see down there. A big rat's nest of Ethernet cables, right? There's all kind of stuff going on here. There's a bunch of junk all over the place. Things look messy. Things are nasty. You're not really sure what's going on here. There's just an absolute lot of information. So you decide to go through all this equipment. You're checking everything out, and you come to find out that none of the switches are working, and you have one router that works. But you have all of this cabling. None of the switches are working, and you have one router. So how are we going to get these devices to work? And by the way, on all of these floors, there are one-to-one connections on these floors. There's RJ45 connections, so they're one-to-one. You have access points that have cabling going all the way down to the IDF, that distribution frame, all that. So everything's already pre-wired. But here's the catch. None of the switches are working, and you go to your boss and you tell them, you say, hey, man, or late, ma'am, I need some help. You want me to get your equipment up and running, and right now we don't have anything. There's nothing. I need some extra help. Okay. So boss comes back to you and says, you know what? I'm going to throw this on you right here. I need you to make it work with this switch. We have 48 devices. I need you to make it work with this switch. However, the boss has another caveat that he's asking. He does not want, let me go back on my picture here so you can see this. He does not want these departments to be able to talk to each other with just main traffic, just regular back and forth traffic. He wants these separated. He wants to get these separated. So you might be thinking to yourself, like, wait a minute. How can I separate these devices, or how can I separate these floors if I only have one switch? That's typically like a subnet, right? When you subnet out something, right? When you use different subnets, you have different switches for these different floors. But in this case, you only have one switch to work with. You only have one switch to work with, which is this one. So what we're going to do is to solve that, we're going to create what's called a virtual local area network. So what you do is pretty much you can take this one switch, and you can divide it into different networks, into little mini switches. And that's how we get away with not having to use multiple switches, with just using one switch, right? Because in this case, the boss showed up with one switch. But this is how we can get all the devices to work, okay, to talk to each other, on the different VLANs, by using these little mini switches. So each one of these little mini switches, we're going to configure a different VLAN for them. So one, in this case, I think an example we had the cell HR department, we had the marketing department, and I think the other department was the sales department. Sorry, I'm trying to use this with a mouse, so it's not all that great, right? So that's the whole deal. That's the whole deal with virtual local area networks. Being able to take a physical switch and virtually divide them up. That's how you do it. You virtually divide them up. So that's how we're going to do this. So let's get in this video. Let's talk about this. So VLAN definitions. VLANs are logical connections with one similar devices. Placing devices into various virtual local area networks have the following characteristics. So as you can see here in this video, right, we have three different switches with third floor, second floor, first floor, but they're all on different VLANs, right? VLAN 2, VLAN 3, and VLAN 4, right? And in this particular example, that has a router as well. So placing devices in various VLANs, okay, provides organization that is more manageable. That is correct. We want things to be more manageable. Broadcast, multicast, unicast are isolated into one individual virtual local area network. So it's going to reduce that broadcast, right? It's going to reduce that broadcast. Each VLAN will have its own unique range of IP addressing. So if you remember in CCNA 1, first part, introduction to networks, right? When we did all of the subnetting, right? When you subnet a network out, you typically have the switches that go with those networks. Well, it's the same process. You can still do the subnetting with the different IP addresses, but instead of using multiple switches, you just use one switch and you virtually section everything off like it's supposed to be. Everything gets sectioned off into smaller little broadcast domains. So the benefits of VLAN designs, as you can see here, we have smaller broadcast domains. Dividing the local area network reduces number of broadcast storms, right? Broadcast domains, excuse me, not storms, apologize. Improved security, only users in the same VLAN can communicate together, right? Improved efficiency, VLANs can group devices with similar requirements, faculty versus students. Reduce costs, you use one switch. This is probably a big one here. One switch for all of that. And then multiple groups or VLANs. Okay, better performance, smaller broadcast traffic, okay, and similar groups will need similar applications for the network resource. So if you take a look at this picture, as you can see here, we have PC1 and PC4, they're on VLAN 10, PC2, PC5 are on VLAN 20, and we have PC3 and PC6, they're on VLAN 30. But take note, these computers are on a completely, totally different network, and these are on a different network as well. So how do we get these machines to talk to each other, but still not broadcast their information to other computers? How do we get VLAN 30 machines to only talk to VLAN 30, right? We're going to get into that stuff. All right, so types of VLANs, we have VLAN 1, which is essentially the default VLAN. If you go into your switch, type show VLAN brief, this is what you will see, right? You will see all of the different switches, you will see all of the different ports assigned to VLAN 1. This is the default. The default native VLAN, the default managed VLAN cannot be deleted. So you cannot change these. There always must be a native VLAN. These cannot be changed. But what you can do, you can make additions and add numberings to this. We can add VLANs. We're going to get into that here in a little bit. So types of VLANs, dedicated user-generated traffic, email, web traffic. VLAN 1 is a default data VLAN because all interfaces are assigned to the VLAN 1. So when you fire up a switch for the first time, when you start plugging in all your devices, they're automatically going to be set to VLAN 1. All right, that is like the default. Good frame of thought, obviously buttheads and hackers, they know that these switches typically are on VLAN 1. So good form of security is basically changing those VLANs, right? Changing those numbers to something that is proprietary, that we understand, that we know, something that's not just like basic out of the toolbox. Native VLANs is used for trunk links only. Okay. All frames are tagged on 82.1q trunk link except for those in the native VLANs, right? And management, this is used for SSH, Telnet, VTIY lines, virtual lines, all layer 2, all that good stuff there. All right, let's continue here. So types of VLANs, we have a separate VLAN is required because voice traffic, this is voice virtual local area network. A separate virtual local area network is required because voice traffic requires assured bandwidth, high quality of service priority, ability to avoid congestion, delay. Okay, yeah, so you can understand voice. It's like voice over IPs, video conferencing phones, they use UDP, which they basically are going to throw a lot of packets out there. Hopefully everything gets in there. There's no verifications that everything's good. It's just going to use a lot, right? Because we want to make sure all that information is where it needs to be. Let's get into the next one here. All right, so we already did that, the packet tracer. All right, so VLANs in a multi-switched environment. So normal VLAN ranges are from 1 to 1,005, excuse me. Use a small, medium network business sizes, okay? You don't need all the big ones right in the small ones, right? But extended ranges usually are a little bit bigger, right? Used for big service providers like your Spectrums, your Verizons, things of that nature. So this is the commands to create a VLANs, and we're going to go through this in our demo. We're going to enter global configuration mode, VLAN, name, end, and configure the terminal, all that good stuff there. All right. So VLAN creation, when you create the VLAN, you got to give it a name. This is how it works. If the student PC is going to VLAN 20, we'll create VLAN first and then name it. So student PC is on VLAN 20. So we would say configure T, VLAN 20, name, we're going to call it student. So we know that VLAN 20 is student. All right, so before we get into the next part of this, I want to show you this picture. This is just a basic general picture of a trunk. That is correct, folks. Just a regular old trunk. And if you take a look inside of this trunk, what do you see inside this trunk? We see luggage, we see backpacks, we see a bottle on the outside, a couple more bags and things of that nature, right? So let's just say, for example, each one of these bags belongs to all these family members that are getting ready to go on a trip. And each bag contains personal items, things that they may need for their trip. And essentially what they do, they leave one little network that they're in and they put everything in a trunk. Everything goes into the trunk. They close the trunk. And what do you think will happen once they get to their destination when they open the trunk? What's going to happen to this stuff? If you probably understand, that's correct. Yep, they're going to grab their packages, their data, and they're going to go to the respectable places that they need to go to. All right, so let's get into this here. Defining VLAN trunks, okay? So a trunk is a point-to-point link between two network devices, point-to-point link. Okay, Cisco trunk functions allow more than one trunk together. Extends the VLANs across the entire network. All right, and by default, supports all VLANs. Supports 802.1q, which is trunking. So if we take a look at these devices, right, those trunks are going to occur on the switches. Right, we're going to trunk these areas so the data can get to where it needs to. So if PC30 wants to see PC6, wants to send it to Marco Polo, items in here need to be trunked so it can get to the switch. We're going to get into that here a little bit. You'll see that. All right. Without a VLANs, right? If things are not VLANed off, you will see a broadcast. Okay, so it's going to broadcast out. Hello, I'm looking for such and such. If you've ever gone to Denny's or IHOP, I prefer IHOP. Hopefully you guys like IHOP. I prefer IHOP. If you go to IHOP and your regular server orders your food, and maybe there's a party of 5, that server leaves, and a separate person comes. Somebody else comes and brings your food. Somebody that you haven't seen before. What do they say? Who ordered such and such and such and such? Who ordered such and such? They're essentially broadcasting out to you so they can deliver your food or deliver your data, right? That's what a broadcast is, right? Very similar to that. So without VLANs, all devices connected to the switch will receive all unicast, multicast, and a broadcast traffic. In this case, the unicast would happen after the broadcast because the MAC address tables will be developed. But still, even with that, with virtual local area networks, there's still more efficiency with that. So with VLANs, unicast, multicast, and broadcast traffic is confined into a VLAN. Without a layer 3 device to connect with VLANs, devices in different VLANs cannot communicate, right? So rules still apply, right? In order for different subnets or subnets to talk to each other, you still need a router to route it, right? You still need a router to route to different VLANs. All devices in different VLANs, they cannot communicate. So obviously we have to trunk these, right? Got to trunk them. All right. So VLAN identification with a tag. The IEEE 802.1Q header is 4 bytes. When the tag is created, the FCS must be recalculated. All right. So essentially, like I showed you in that picture of that trunk, when somebody puts all their materials when they put all their materials and luggage into the back of the trunk, they've pretty much ID'd what that is because they know that's what their stuff is. When they get to the destination, they grab their bags, right? Very similar to how networks work with these VLAN tags. When sent to end devices, this tag must be removed and the FCS recalculated back to its original number. So there's a VLAN ID that gets tagged, okay? So let's talk about native VLANs, okay? 802.1Q. Tagging is typically done on all VLANs. The use of native VLANs was designed for legacy use, like the hub in the example. Unless changed, VLAN 1 is the native VLAN. I told you, VLAN 1 will always be the native default VLAN. But both ends of the trunk must be configured with the same native VLAN. So in order for that trunk to work, they have to have the same VLAN. They need to know the same VLAN information. So both ends of the trunk must be configured. Each trunk is configured separately so that it's possible to have different native VLANs on separate trunks. So voice VLAN tagging, voice over IP, phone is a 3-port switch. Phone will tag its own traffic, and it can be cost. It can set a cost of service, so how much it costs for that information to get there. And as you can see here, we have VLAN 150 configured here. It instructs the phone to tag a voice frame. So this makes all the voice over IP information a lot faster. Really, really quick there. All right, so let's say you're into a switch. This is what it looks like. We're going to type in the show interfaces switchport command here. And you can kind of see what we're looking at here. In this case, it shows if it's enabled, static, if it's trunking, right? There's that duplex there a little bit. Auto negotiate, all that good stuff. If it's native, in this case, it looks like the trunking is off. VLAN 20, as you can see here, voice It's all self-explanatory there. All right. So let's take a look at a couple VLAN configurations. Let's go through this, and then we're going to get into the demo, right? So VLAN ranges, and this is to show the VLAN brief, okay, from the Cisco switches 2960 and 3650 support over 4,000 VLANs. That is a lot. That is a whole lot of VLANs, right? All right, so let's get into the next segment here of Module 3, and we're going to talk about switch modes. So to give that illustration, let me explain what you're looking at here. So this is basically a normal train track, right? And in order for a train to go down a different portion of the track, it has to switch. The train track has to switch, right? So let me show you something. So watch this video, and I want you to see the train track switching left and right. See that there? It's just moving. So if that train were to come down, it would switch. I'm sorry, if it was going this way, it would switch and go down this way. If the train track moved to the right, the traffic will go down this aisle here. And as you can see, there's other switch areas there as well. So what does this have to do with networking? What does this have to do with the switch? It's very similar. I want you to think of these train lines as Ethernet cables. Okay, and the data moves on these Ethernet frames on these cables, right? In order to take that Ethernet cable and switch it to a different track, you're going to have to switch it. You got to program it to switch it. It has to be switched. All right, so let's get into this here. So once a VLAN is created, we can then assign it to the correct interfaces. So we're going to enable configuration mode. We're going to go to config terminal interface. And that command, as I told you, they showed you the example of the train track switching. The command is called switch port mode access. That is the command. We're essentially going to take that Ethernet cable, all the data from that cable, and we're going to switch it to a different VLAN in that switch. Very similar to that train track, how the train just, the tracks just switch to go down to a different track. After type in switch port mode access, we're going to type in switch port access, and we're going to access the VLAN that we need to have the data go to, and then we're going to end after that. So we can assign the VLAN ports. Once the device is assigned, the VLAN then end device will need an IP address information, all that good stuff. So you still got to have an IP address. You still need IP information, right? But what we need to do is we have to configure the actual interfaces, right, to those switch ports. Here's that train track. Okay, so inside of the switch is that train track. So we're going to have to switch port mode access to the different VLANs inside of the switch, whichever we decide to create inside the switch, okay? So in this example, it's interface fast Ethernet 18, because that's what this cable is. It's plugged into here. Switch port mode access, we want that to go to VLAN 20. VLAN 20, that's what's looking here. So data and voice VLANs. An access point may only be assigned to one data VLAN. However, it may also be assigned to a voice VLAN for when the phone and the end device are off the same switch port. So these are some examples. VLAN 20, name student, VLAN 150. So they created a VLAN called 150. They call it voice. And they exited and they went into the interface where they created it at switch port mode access to VLAN 20, okay, and then switch port mode into VLAN 150. And you do the type in the show VLAN brief, show VLAN summary in this case, and this kind of gives you the breakdown of all of the information. So let's get into the demo right now. Okay, so for our demo, I have 4 machines set up. Let me blow this up a little bit so you can see. I've got 4 computers set up. And as you can see here, I have PC1, PC2, PC3, PC4. I have 2 switches that are connected with a crossover cable in between. PC1 and PC3 are part of the admin VLAN, and PC2 and PC4 are part of the sales admin. So what I'm actually going to do before I continue, I'm going to call the admin VLAN 10. Okay. So all admin computers will be on VLAN 10. They're just kind of doing this preset here. I'm going to go over to the sales department here, and we're going to call the sales department. We're going to put that on VLAN 20. So that's VLAN 20. This helps me as a reference so I can see when I'm configuring things of that nature. So VLAN 20. Okay. All right. So we got those numbers set up. All right. So right now there's nothing set up in the switches. Everything is brand new. This is a brand new setup. Just started packet tracer, did all that stuff. So right now, what I want you to see before we set all the VLANs, I want you to see what the network is going to do. Right? You should see a broadcast happen when the first packet gets set up. All right. So just to show you really quick, let me get into the switch. All right. I want you to see this. I'm just going to type in enable show MAC address table. As you can see, actually there's one in here, right? There's one MAC address because that's associated with the trunk part. We're going to go through that here in a minute. All right, so I'm going to go into the PC. I'm going to go to command prompt, and what I'm going to do, I'm in PC1. I'm going to ping this computer right here. So let me turn on the simulation so we can kind of see the packets move, simulation mode. I'm going to go over here. I'm going to type in ping 192.168.1.3. All right, here we go. So I'm going to set the ping. Press enter. Let's move this out of the way. There goes the initial packet to the switch. Look how I broadcasted this to this switch. Obviously, we get an X because that's not the IP address that I pinged. What should we see here, right? We probably should see a broadcast in this section here. Yes, that's exactly what it does. This computer says, nope, that's not me. Look at the ARP. It does ARP, okay, because it knows the IP address. So we have an ARP there. Mail goes back to the switch. Goes back across the network again, back to the switch. It says, hey, I received your Marco Polo, and it goes back and does it again. Okay, now it becomes a unicast, as you can see here, and so on, right? So you can see how it gets the initial setup, right? The initial ping, it gets broadcast out, right? The initial broadcast happens. Let's go to PC2. Let's go to PC2, and we're going to ping PC4, which is the sales computer. So we're going to go ping 192.168, not 138, 168.1.4. And let's see what happens. So we have the starting packet here. We're going to ping this other sales computer. We're going to ping here. So there goes the broadcast of this. It says, hey, I'm looking for 1.4. Same thing happens here. We get a broadcast here. That information goes back. Then it goes back to the switch, and it says, yep, I found him. Here it is. Let's send it back. Get another Marco Polo, back and forth. And there we go, right? So same thing would happen again if I were to ping using this machine. So if I ping PC3, the PC1, vice versa. I can even ping, because everything's on the same network. I can go in here right now and ping this computer right here. Let's ping this machine right here. All right, just for the heck of it, right? Let's go Control C. We're going to ping 192.168.1. Let me move the thing over. dot 3. Okay. Let's see what we get there. There goes computer. Goes another broadcast out because we haven't pinged that machine. And it broadcasts out again. It says, yes, that's me. Turns it to a unicast, and it goes back, and bam, there it is, right? So as you can see, when we don't have VLANs, typically everything is going to get broadcasted out. Everybody's going to get to, hello, how are you? What's going on here, right? We want to kind of tighten that up, right? We want to kind of narrow that traffic a little bit. We want to secure that traffic a little bit more and tighten it up. So let's take a look at that, see what that looks like. All right, so the first thing I like to do, let's turn off the simulation mode. Typically, the first thing I like to do on any switches, right? If I'm configuring end user, in-host, switch, router, you got to do the basic configurations and you got to lock it down. That's kind of always a standard practice for me. I always like to get in there, and I like to go in there and lock the machine down, lock the switch down, because you never know in the business, you may have to leave and go do something, and you don't want anybody else coming in to change any of your work, because if you're in charge of it, you need to make sure you're in charge of it. Okay, yeah, make sure you're in charge of it. So I'm going to get into the switch. Let's do it let's do it the hard way. We're going to add in a console cable to do it that way. Okay. All right, so I'm going to get to the switch, and let's start doing the basics. Okay, basics of the switch. Uh-oh. All right. So we are going to enable secret, right? Line console, banner, all that good stuff. So let's do that now. Let's go config T. Line console 0. Password, let's call it Cisco, and we're going to log in. We're going to exit out of that, okay? And we're going to enable secret, and we're going to call that class. Uh-oh, I called it CLSS instead of A. Let's do that one again. Secret and class. There we go. So we got that going there, all right? We're not going to do the VTIY lines. We're not going to do any of that stuff right now, so we won't worry about that stuff. But we will do is that we'll change the host name, right? So we'll go host name, and we're going to call this switch. What switch is this? It's a switch 1. So host name S1. Very good. All right. So if we look at that, let's make sure that's good there. There's a password. Password is Cisco, and enable secret is going to be class, and bam, there we go. We are in. Now, we'll do all the other stuff later, service password encryption and all that stuff, because we're going to stay on this machine, right? Everything is good here. All right, we got to do the same thing to switch number 3. This switch here, we got to do it to that one as well. So let's add the console cable here. All right, so same thing. I'm going to go enable, config T, line, console 0. We're going to put password Cisco, log in, exit. Okay, we're going to enable secret, call it class, exit. And we're going to change the host name to, go back to config T, host name S3, I believe. This is switch 3. Yeah, switch number 3. All right. Bam. All right, so we just did basic stuff. Obviously, you still should do banner of the day and all that good stuff. But for right now, we're just sticking to just the basics on this. Line console so we can get into it. Enable secret, all that good stuff. So in case I ever were to step away from this device, I know all the information. I can get back to it. It's locked down. Everything's good to go. So, all right. Let's go back to switch number 1. Now it's time to create these VLANs, right? we've got to get these VLANs created. Because right now we have 2 VLANs that we need to create. We have VLAN 10 and VLAN 20. So before we do that, let's type in the show VLAN brief. And let's kind of see what we got here. Let me move this over this way so you can see and get it out of my head here. So let's see what we got here. Right now on switch 1, we have our default, which is our native, right? As you can see here. And these are all the ports that are assigned to the default, right? When you first initially turn on your switch, it's going to do that. You're going to send the default. But what we want to do, we want to create our VLAN. So let's do that. Here. So we're going to go config T for configure, okay? We're going to type in VLAN 10. Take note, see where it says VLAN here, right? VLAN 10. And we're going to name it admin. Exit. Okay. We're going to do the same thing. VLAN 20, as you can see here. Config T. VLAN 20. We're going to call that sales. Exit. All right. So let's double check. Let's make sure everything's working there. So let's see. Show VLAN brief. There we go, folks. So as you can see here, we have VLAN 10 set, admin, and the 20 sales. All right. We're not done yet because we're gonna create the native VLAN. Right now the native is set to 1. We're gonna change that to VLAN 99. All right. We're gonna call it VLAN 99. So let's do that now. We're gonna go config T. VLAN 99, name native. Oops, sorry. Native. Okay? Native. Spell native wrong. Sorry. Crazy. All right, I'm going to exit. Exit again. Write memory. Show VLAN brief. And there we are. So we have our 3 VLANs that are created. VLAN 10, we have VLAN 20, which is sales, and our native VLAN, which is VLAN 99. All right. Same process has to be done on switch number 3. Okay. We did switch 1. Now we got to do switch 3. Same process. So let's go into terminal. Let's get into our switch. Exit here. Okay. We're going to go config T. We're going to go VLAN 10. Name is admin. Okay. Exit there. We're going to do VLAN 20. And we're going to call that sales. Exit. Okay. And now we're going to do VLAN 99, and we're going to give that the native name. There we go. Our VLANs are set. All right, so exit there. Boom. Let's go show VLAN brief. And boom, there we go. So we have our VLAN set. Everything's good to go on this switch. VLAN 10, VLAN 20, which is sales, and VLAN 99, which is our native VLAN. So we're good to go, right? Are we good to go? Oh, sorry, I had to sneeze. So we're good to go, right? Everything's good to go? Should we be good to go? No, we're not. You guys remember that switch port, right? Remember the train tracks. Because right now, if you take a look at these, and I'm actually going to pull up the other side too. So we have switch 3. Let's pull up switch 1. Okay. If you look at these side by side, we can see that the VLANs are created, but the switch track, right? The switch track it's still on the default VLAN, right, which is default VLAN number 1. So if I were to send a ping right now to these, we still should get what we normally got last time with the broadcast. But we have to switch these. We have to change these up. We have to switch the switch track, right? So let's do that. Take note before we do this, right? We're going to change these VLAN ports. These switch tracks are going to go on the different VLANs. As you see, I'm highlighting them here. You can see what interfaces that they're on, right? So if I highlight it. Okay. So right now we're going to work on 1-1 for this switch number 1, and we're going to give it the sales VLAN. Now, one thing I do like to do, okay, I know we're working on 1-1. Some things what I do like to do sometimes you may not see it, right? It may be hard to decipher which cable is plugged in here. I mean, you can look at the MAC addresses on the machine, you can do IP config, do all that stuff. But I like to do things harder sometimes because it's easier for me to process sometimes. I can see it. So what I'm going to do is I'm going to go config T. I know we're looking at interface 1-1. And so if I put the cursor right on it, I think that's what it was. It was 1-1, right? So what I'm going to do is I'm going to type in interface fast Ethernet 1-1, and I'm going to type in shut down. Now, if I have the correct cable that I'm thinking of right here, we should see this thing turn red. Let's take a look. And yes, it does, ladies and gentlemen. Ching ching, it does turn red, right? So I know we are working with the correct cable. We're working with 1-1. All right, so let's try this. Let's go back to no shut. We want to turn everything back on. All right, so here we go. Watch the command here. This is what we're going to do. Let me move this over here so you can see. All right, so the command is this: switch port mode access. Okay, there's that train track, right? Switch port mode access. Switch port access to, now we have to tell it where we want that train track to go down. We want it to go to VLAN 20. We want it to go to VLAN 20 right here. VLAN 20. This is the VLAN that we're working with, okay? VLAN 20. So access VLAN 20. All right? Now, let me explain this really quick. I want to make sure you guys understand the reason why we selected VLAN 20 is because this computer port is plugged in to the interface 1-1. Okay, 1-1. That's the interface on the switch, and we want to create the VLAN on this side for this computer. VLAN 20 is what we are setting that is what we're setting 1-1 to. That's exactly why we put this on 1-1. Okay, so I want to make sure we understand that. All right, so that's done there. Okay, so we did switch port mode, switch port access VLAN. Okay, so we got that there. One other thing we're going to do is we're going to, okay, not yet. We need to get to the other side first. All right, so let's go exit here and exit again. And let's run our cursor on this side here. Let's see if we can get any action here. Let's see here. And I'm telling you, I already know this is going to be, there it is. So this is Fast Ethernet 0-1. This is the side we're working with, Fast Ethernet 0-1. So let's verify. Let's go config T. Okay. Let's go interface Fast Ethernet 0-1. And I am going to type in shut down because I actually want to see it shut down. There it is. It is in red. So because it's red, I know we are dealing with the correct switch here, right? We're dealing with the correct cable. We got the right machine. We got everything we're working correctly here because I turned it off. Let's get in there and turn it back on. No shut. There we go. Now, we need to configure this line, this interface, Fast Ethernet 0-1 to VLAN 10. Let's do that. Okay. Actually, yeah, we're going to switch port. So we're going to go switch port, mode, access, switch port, access to VLAN 10. There we go. So we changed the switch port. Now, let's verify that. Let's see what we got here. Let's go exit out. I'm going to type in show VLAN brief. And if you can see right here, we indeed have it correctly. So we have VLAN 10 admin on fast Ethernet 01. And then we have VLAN 20, which is the sales, on fast Ethernet 1-1. Okay, so here's VLAN 20, which is the sales computer, is on the sales VLAN, right? I believe this was what did we say here? It was 1-1, right, for the sales, and this side is 0-1. Okay, so if I point the cursor over there, and you can see that too, it should be over there, right? All right. Let's get into the third switch. Folks, we're almost done. We're almost done here. We're almost done. All right. So let's get in the terminal. Let's do the same things. As you can see, they are not configured. Now, you may be thinking, because I ran into this trouble, I ran into some of these challenges with people in the past, so I want to make sure we're thorough with everything. Don't necessarily, what we did on switch 1 is not necessarily the same as switch 3. Okay, you got to be mindful of what you're setting the VLANs to. Okay, for example, we already know here we set 1-1 to VLAN 20 for this computer, for this network. But let's take a look here. This switch is also 1-1. See if I get this to light up. All right. Uh-oh. I lost it. 1-1. Okay. I just added it because I messed up there. There. 1-1. But this switch is going to be configured to the admin VLAN. Very important. This is going to be configured to the admin VLAN. So if this is 1-1, that means this side is 0-1. This is configured to the sales VLAN 20. Whereas 0-1 up here on this other switch was configured to the admin. Why? It's because physically these computers are on different switches, right? These are on totally different switches. So let's get into it, right? So we're working with 1-1. So we know this side here is 1-1. We're going to set that to admin. We're going to set that to the admin, right? All right, so here we go. We're going to go config T. Yes. We're going to go, let's see here, switch port. Uh-oh, nope, I forgot to get into the VLAN. Sorry, so we have to get into the switch. So interface, fast Ethernet 1-1, right? Again, I want to make sure that I have the correct one just to be sure. This is like just to want to be sure. So I'm going to type in shut down, and as you can see, it turns red. So I know that this is the correct one that we're working with. We're going to put this on VLAN 10, right? Because I just shut it down. Now let's turn it back on. Let's go no shut. There we go. All right. So now we're going to switch port this to the admin VLAN, which is VLAN 10, right? So here we go. Switch port mode access, okay? Switch port access to VLAN 10. There we go. VLAN 10. So this port is configured to VLAN 10, all right? So now we have to configure this side, which is 0-1. So let's exit out of this. Okay. We're going to go interface fast Ethernet 0-1. Again, I want to double check, right? I want to make sure that I am working with the correct one. I'm going to type in shut down. There goes, folks. As you can see, It does turn red. That means I did shut down the correct port. Let's go back to no shut. Everything's going on. We're back on. I know I'm working with 0-1. Okay. So now I'm going to type in switch port mode access. Switch port access to VLAN 20. VLAN 20. Okay. VLAN 20. There we go. Exit. Right. Exit again. And let's write memory. And let's take a look. Let's go show VLAN brief. And voila. There we go. So we have 1-1, which is this side, set to the admin. Sales, right, which is a 0-1 set to the VLAN 20. Okay, set to VLAN 20. Hopefully you guys can see the differences here. Let me pull both switches up so you can kind of see this. So this was switch 3. Let's pull up switch 4 so you can see the differences between the two. Because they're going to look very much alike. Okay? Take note. It's actually, you can see it. This switch, PC1, which is, we're doing a console in, the switch 1, okay? Admin, active, okay? Admin, fast Ethernet 0-1, whereas on switch 2 is set to 1-1, okay? That's where the difference is. Sales is set to 1-1, where sales on the other switch is set to 0-1, all right? That's how we get the differences between these two machines, right? Because both of these computers are on different VLANs. That's why we have the differences between them. That's why they kind of switch there, okay? All right. So now, let's get to the next step. Now we should be able to ping the computers, right? Yes? Let's test it. We should be able to ping. I should be able to ping this admin computer right here. Let's try that. Let's go ping 192.168.1.3 and give me my Marco Polo. Hurry up. Uh-oh. It timed out, folks. It timed out. They should have done that. Let's try that again, because that shouldn't have done that. I don't know why that's doing that. Let's actually put it in simulation mode so we can actually see it, right? Let's see what's going on here. Okay, let's see what's going on here. Uh-oh. So as you see on the machine, right, we got timed out. Nothing's happening. So why is that, folks? Why do you think that is? Why is this timing out here? Why are we getting this timeout? So why didn't it work, right? Well, if you guys remember the trunk, remember all the items that go into the trunk? A trunk is meant to house all of the VLANs together, so we can kind of bridge the different switches, right? So let's do that. We're going to type in interface. I'm sorry, not the VLAN. I apologize. It's going to be interface fast Ethernet 2-1. Because remember, we want to trunk this port now. Because we're working on 2-1. Okay. I'm going to press enter. Now watch this. We're going to type in. Let me get this going here. We're going to type in switch port mode trunk. Okay. Okay, so now we have a trunk. Notice that the colors have changed in the cabling, right? So there's some negotiation stuff going on, all right, with those things. Now what we're going to do now is we're going to take that native VLAN. Okay, we're going to remember the native was VLAN 1. Now we're going to make the native VLAN 99. So watch this. We're going to go switch port trunk native VLAN 99. Okay. And now what we're going to do is we're going to tell the switch to enable all the other VLANs together, right? So we can house it, put everything in the truck. So we're going to go switch port trunk allowed, and we want VLAN 10. We want VLAN 20, and we'll just put 99 in there as well. Uh-oh, I screwed up there. What did I do wrong here? Oh, you know what I did wrong? I forgot to put the VLAN in front of it. That's my fault. There we go. So now we allowed that trunk to hold all of those VLANs together, right? Exit, write memory. All right, let's go to show VLAN brief so we can kind of see everything. Bam, that looks good. All right, now let's go into PC2. I'm sorry, yeah, let's go to PC4. We're going to go into the switch, and we need to do the same process. All right, let's move you over this way. Now, take note. I want you to see. Right now, because I trunked this port on the switch number 1, look what's happening in switch number 2. We're seeing a VLAN mismatch discovered on Fast Ethernet 2.1. So we're getting issues, right? Things are not working correctly. That's automatic, right? There's already a mismatch there. That's because we haven't finished configuring the other switch. So let's do that now. Okay. All right, so we're going to go config T. All right. Okay. So we're going to select the interface Fast Ethernet 2-1. And again, the reason why we use 2-1 is because this is our access port right now. This is the switch that's connected to the other switch with the crossover cable, right? That's why this is the port that we're going to trunk. We're going to trunk this port, right? Okay. So we're on that port. So I know I keep moving this. I apologize. So we're on that port. So now that we're on that port, we're going to type in switch port mode trunk. There we go. We're not done. We got to set the native VLAN now, right? So we're going to go switch port mode. Okay. I'm sorry. Switch port trunk native VLAN 99. Okay. There we go. Now it says port consistency restored. There it is right there. So now these two ports are working correctly like they're supposed to, kind of like that have different speeds, different duplexes, right? When you have one side working the other side differently, you're going to get that collision, right, in the road, okay? Now we need to allow the trunks on there, right? So let's do this. We're going to go switch port trunk allowed VLAN 10, 20, and 99, which is a VLAN, which is the native. There we go. Exit again, and write memory. All right, folks, let's take a look. We should be set here. Let's take a look, see what we got. So now let's ping. Let's see what we get. We're going to ping PC1. We're going to use PC1 to ping PC3, which is on the same VLAN. Let's see what we get. Remember, VLAN traffic is proprietary to that traffic only. So let's see what we get. We're going to type in ping 192.168. Let me move this over so I can actually see it. .1.3. That's what this IP address is. Let's see what we get. Look at that, ladies and gentlemen. There it is right there. We just got a reply back. There it is. So that packet got to the other VLAN through that trunk. Yes, we did. Let's do it the other way. Let's see if we got, let's ping the other VLAN. Okay, so we're going to use, let me get myself out of the way so you can see better. Okay. So we're going to go ping 192.168.1.4. So now we're going to ping this computer. Okay. This time, let's turn on the simulation so you can actually see it happening. Okay. Here we go. Let's advance it little at a time. There goes the packet to the switch. There goes the trunk. Everything's in the bag. Everything's inside the trunk in the car. Opens it up. Everybody gets their contents. It hits the computer because it knows the VLAN. It comes back. And there it goes again. And there you go, folks. There's our process. There's a unicast now because it knows. And there we go. So let's just try it. Let's just see if we can ping another computer. Let's see if we can ping VLAN 20 from VLAN 10. I doubt it, though. I highly doubt it'll work. Why? Because the VLANs are separate. But let's see. Let's just try it. Let's just see what happens. So ping 192.168.1.2. And yes, it does time out. And the reason why it times out is because VLANs are, let me show myself here. VLANs are virtual switches, little mini switches in between each other, so it can't see each other. I would need to install a router in this network in order for that VLAN to work correctly in that department there. Okay? So let's do another one. Just make sure we see this here. Let's go to VLAN 20 from here. Okay, which is the PC4, and we're going to send a ping to this computer right here. So let's do it. Let's go ping 192.168.1.2. There it is. We are good. We are seeing the ping go through, the Marco Polos, and we're all set there. So now we've configured the switches for trunking, configure these ports to trunk like they need to. We did the switch track, switch mode access, so all that's good to go. All right. All right, so this is going to conclude Module 3, VLANs, Virtual Local Area Networks. Make sure you like and subscribe to the YouTube channel. Follow me at TandyIT, and I'll see you on the next video.